Hi everyone. This video is nothing but the continuation of your previous bit stuffing protocol. Okay. So in this video, I'll be going to discuss character orient protocol, or I can tell you character stuffing. Okay. So as you saw previously, that is bit stuffing, same concept applies here. Only changes there is in terms of bits here, in terms of characters here. Similarly, this is the flag pattern. Okay, or frame format, sorry, not flag pattern, frame format it is. So here also you can see here, so what happens here, it consists of a start flag, it consists of a end flag. Here also there will be a flag pattern, but there is no predefined flag pattern here. Okay, again I repeat, there is a start flag, there is an end flag, but there is no predefined flag pattern here, but there is a flag pattern here. And this address, this is FCS, and this is nothing but variable data, or it is in terms of characters coming from the upper layer. Okay, so this is your frame format. Okay, now we'll take an example here. What happens means, you can read out this one. So what is happening here, byte stuffing or character stuffing is the process of adding one extra byte whenever there is a flag or escape character. Okay, now what I'll tell means, now take this one as an example. See here. Okay, so this is, consider this is coming from the upper layer. Okay, and this is the actual data. Okay, now why we are doing bit stuffing, why we are doing stuffing, because flag, if it is present in the data, okay, that will be considered as the flag. Okay, in the data the flag pattern will be considered as the flag. Okay, and the remaining will be considered as the data. So what happens, there will be loss of information. Because of that reason, okay, we are doing stuffing. Similarly, here we are doing character stuffing. Now you see that there is a flag pattern present in your actual information. So something has to be done. Suppose if this is considered as the flag, means there will be loss of information. So something has to be done. So what has to be done? See here, we need to add one extra byte. Okay, one extra byte before. Okay, before this, once you recognize a flag pattern in your data, before the flag pattern, a byte has to be inserted. Okay, that one extra byte whenever there is a flag or a escape character in the text. Okay, so see here, what happens here, there is a flag. Okay, before that something is added, that is called as escape. Okay, that is called as escape here. Okay, next. Okay, next. Now similar, this escape character is also, you will be in terms of character. Flag also will be in terms of characters only. Okay, that is one thing. This is one thing, whatever you saw. This is how the flag pattern is avoided in the data. Okay, now suppose an escape character only is present in your data. Okay, suppose the escape character only is present in the data, then what you will do? Okay, now suppose if you leave it like that only, the escape character, again this will not be considered. Okay, again there will be loss of information. So now something has to be done. Now what he is telling means, if you find an escape character in a data, okay, before that you add one more escape. Okay, you add one more escape. Okay, that is what adding one extra byte, okay, before the flag pattern or escape character. Okay, before the flag character or escape character, that is what it is. That is done at the sender side. Okay, now coming to the receiver side, so what it will do, whenever it identifies a first escape character, the next one is considered as data. Okay, this is considered as data. Similarly, when further it goes, okay, then it finds that first escape. So what it will do, it will consider the next character as what, as data. Okay, so nothing is lost. So same thing you achieved here and same thing you achieved here. So this is the actual information you got without the error. Okay, so this is clear, I think. Now in your example, your flag pattern, okay, in your example, what I'll do, this flag, okay, I'll write it as here. Before going into the program only, I'll tell what is your flag pattern. Flag is equal to DLE, something you can take anything. DLE is the flag, and here also the flag is DLE. Okay, now just I'll clear this everything and write here. Okay, flag pattern is equal to DLE, and here flag is equal to DLE. And what is your actual data? Okay, here the actual data, I'll write it as, okay, KS, I think I need to write here. Okay, KSIT, sorry, you can write it in small letters or capital letters, KSIT DLE. Okay, now what happened? Okay, now what will happen? This is what, suppose if you're not doing any stuffing, okay, if you're not doing any stuffing, okay, that is character stuffing, if you're not doing, so it will directly enter into the receiver. Okay, it will enter into the receiver. Now this one, whatever DLE, okay, this DLE, okay, will be considered as what? Will be considered as flag. Okay, or in another way, if I want to tell, okay, if I write it here, KSIT DLE, if I write, okay, now what happens here? This, when it reaches receiver, then only it will do. When it reaches receiver, what happens if you are not doing stuffing here? When it reaches receiver, what DLE will take means DLE is a flag pattern. So this is flag, correct? This is flag here. Okay, now what happens, since it is a flag, it indicates the end of the data or end of the frame. So what is the actual information you'll be getting? The actual information you'll be getting is only KSIT. Okay, okay, data, KSIT, data received. Okay, received. But what is your actual data? KSIT DLE. So is this data you received completely? Okay, so this one is wrong. Okay, your actual is KSIT DLE, but you got KSIT because this DLE is considered as end of the frame. I can write it as, okay, this DLE is considered as end of frame. Okay, which one? This one, DLE. Okay, this is the problem we'll fix. That's why we need to stuff the data. So similar example I am considering. So now we'll go enter into the program. Okay, so further moving. Okay, now you can see here. Okay, so this one you know, and why it is string.h, because we are taking string of characters here. That's why. And this I is equal to 0. For I is taken for the purpose when we are taking each and every character, okay, for that purpose. And J, it is taken after stuffing, okay, after stuffing. And N is nothing but whatever the string you give, that the length, okay, it defines the length. And A of 20, A of 20 and B of 20. As I told you, this A is for the input data, input characters, each and every character you are considered. And this one is nothing but after stuffing. Okay, so why it is 50 here, why it is 20 here? You know that input can be what? KSIT DLE. Okay, but after stuffing means nothing but there should be a flag present here. Okay, after stuffing there should be a start flag and end flag. So that's why it is 15. Again I'll repeat, A of 20. Why A of 20 means you are considering only the input information. Okay, whereas B of 50 means along with the input information, okay, it consists of the start flag and end flag. Okay, for that purpose only it is A of 50, A of B of 50 it is. Okay, further moving. Okay, now we'll enter the string here. So same example, KSIT DLE. Okay, now here I'll write DLE is your flag pattern. It is actually the flag pattern. Okay. Okay. Now here it is scanned here. Next here, what is the string length? String length is equal to n is equal to 7 here. Okay, because KSIT DLE total 7 it is. Okay, now what happens? Now you started with after. This is after stuffing. You need a what? I'll write it here, flag. Okay, flag. Then information, and then flag. Okay, then flag. Okay, now this one. Okay, this is how it is. Now this one and this one. Okay, now here, if I want to tell here, you will write it as DLESTX. Okay, DLEXTS. Here you have data. Okay, here you have DLEETX. Okay, anything. Okay, so DLESTX stands for starting frame. It signifies the starting frame. DLEETS stands for ending frame, and this is your actual data you need to stuff. Okay, character stuffing you have to do. So this part is nothing but this one. Okay, so how much it takes here? B of 0, B of 1. As I told you, after stuffing, it needs B of 50 we are written. Okay, so you can see here B of 0, B of 1, B of 2, B of 3, B of 4, B of 5. It is taken by DLESTX. Now where J stands with 6 here. Okay, remember at this position, okay, at this position, I is equal to 0 and J is equal to 6. Okay, so hope you are getting. I think we'll further continue here. Okay, so okay, like that only will move. Okay, so here what is actual one? DLEETX. Correct. This is how it is. Okay, now we'll see here one by one. Now what happens here? I is 0, J is 6. So A of 1, A of 0 is equal to what? A of 0. Now if I write this one, so what I'll do means I'll rub this. Okay, just I'll write it bigger. K S I T D L E. Okay, so assume that case sensitive. Okay, case insensitive. Okay, sorry, case insensitive. So now what we can do means first we'll consider this, which is nothing but here. Next, that is A of 0. Okay, A of 0, A of 1, A of 2. Okay, that is what we need to write here. Okay, A of 0 is equal to what? K. Next, A of 1. Okay, A of 1 is equal to yes. Then A of 2 is equal to I. Okay, it compares whether it matches, whether A of 0 is D, A of 1 is L. Okay, A of 2 is I, A of 2 is E. No, it doesn't match here. So this condition doesn't satisfy. So it will not enter into this loop. Now what is this one? It says that A of 0. Okay, it says that A of 0 is equal to what? K. Now which is red? Now K is red. Okay, now what happens? I is equal to 1, J is equal to 7. Okay, now again what happens here? This I will become, now again it will go back here. Okay, now this will become 1. Okay, and this will become yes. Okay, and this will become 2. Okay, and this will become what? I. Okay, and this will become 3, and this will become T. Correct? Again, this condition doesn't satisfy. This also doesn't satisfy. Now you can write A of, okay, A of 1 is equal to S. Okay, so what happened? This S is read. Similarly, it continues for what? It continues for everything because it doesn't match here. When it will match, I'll tell. Now what happens? It continues for A of 2. It will read as I. Okay, then I'll write here A of 3. It will be read it as T. Okay, it will be read it as T. So when A of 4, now what I'll do, I'll just clear everything. So now what happens? The next, when we know the next is okay, after this A of 3, it is read. Okay, at this position, okay, at this position, A of 3 is equal to T if it is read. Okay, now what happens? I would have incremented to what? I incremented to 3. Okay, and this is what it would have been read. This is 6, 7, 8, 9. Okay, this all is completed. I is completed, T is completed. So now I is equal to 3. 0, 1, 2, 3. Okay, now 0, 1, 2, 3. So now 3, and J you can consider it as previously 6 it was. So this will be 6, 7, 8, 9. Now it will be 10. Okay, this is 9. Okay, this is 9 actually. This is 6, 7, 8, 9. Okay, 9 it at present. Now what I'll do means I'll erase everything. Okay. Okay, now we can see here what happens. Okay, this is little bit, it will take time. Okay. Okay, now at present, okay, at present, now what happens? I is like 0, 1, 2, 3. Now it is 4. Assume that it is 4. Okay, now I is 4. Sorry, here. Okay, I is 4 and J, okay, is 10. J is 10 now. Now again it will go back here. Now the process starts here. Now what happens here? Okay, A of 4 is equal to D. A of 5 is equal to D. A of 5 is equal to L. A of 6 is equal to E. Okay, 6 is equal to E it is. So what happens here? Condition. Now the condition D, D, L, L, E, E satisfied. Okay, now this condition satisfies. Now what is J? Now J is nothing but what? J is at 10. Okay, now what this will become? Now you can write it as 10 plus 3. 10 plus 3 is equal to 13. That is equal to J here. Okay, now J is 13. So you can write here J is equal to, here what happens here? A of which one? A of which one? A of 4 is equal to what it has read. A of 4 is equal to what is there? D. Okay, that will be read and it will be stored in where? B of 13. Okay, B of 13 it will be stored. Okay, B of 13 is, it will be stored. Before that, B of 13. Okay, what about 11, 12, 13? Okay, sorry, 10, 11, 12. So 10, 11, 12 will be escape. Okay. So here you can see here, this is nothing but 10. Okay, 10 position. And this is nothing but 11. Okay, and this is nothing but 12 position. Okay, that is B of 10 is E, B of 11 is S, B of 12 is C, meaning that what it is typed here. Okay, first it has read K, then S, then I, then T. Okay, now it will read D. Okay, before reading D, okay, E, S, C. Okay, then now it will read D. Similarly, it will start reading. Similarly, what next it will read what? A of 5. A of 5 is L. A of 6 is E. Like that it continues and it will read L and it will read E. Okay, so this ends. It will start incrementing. I will increment, J will increment. Okay, corresponding. So for example, so at this position, what is J value? 11, 12. Okay, so your J value is here. This is 12 means, okay, and I can write it here. This is 13. Okay, sorry. Okay, this is 13. This is 14. Okay, and this is 15. Which one? Your J. Okay, that is J. Okay, so that completes here. J is equal to 15. And I, as you know that one, I is 0, 1, 2. Okay, this is 3. Like that it continues. Okay, so this will be 4. Okay, this is 4. Okay, and this is 5. Okay, and this is 6. Okay, that is I here. Okay, this is how it continues. So now at present, what happens? 6 and 15. Okay, 6 and 15. So it will start increment. Next, what happens? Okay, this will not get incremented. Okay, now J, what happens? Next J, this will become 7. No data to read. Okay, so no data to read. What is next one? Next is 16. Okay, now if I go further, okay, if I go further, if I clear this, okay, okay, now what is J15 now? Now here I can write it as which position? J16th. This will be 17th. Okay, this will be 18th. Okay, this will be 19th. Okay, and this will be 20. Okay, and this will be 21, and this will be 22. That is null, not required. Okay, 21. Okay, this is how it will be. Now what is your final? This one, this will be ETX here, DLE ETX. That is this. Okay, after the information is stuffed, character stuffing is done, you have to go with flag pattern. That is DLE ETX. That is shown here. Okay, next, finally, what is the frame after stuffing? Okay, so we will clear everything, and finally the frame which is stuffed, I'll write it here. It is D L E E T X, then K S I T D L E, then you'll have D L E E T X. Okay, this is the stuffing. Now you can see here, if I want to separate it, DLEETX is what? Flag. Okay, flag. KSIT, sorry, here I missed here. Here you need to stuff what? ESC. Okay, then this one is again flag. Okay, this is flag. Okay, what is your actual data? Okay, actual data is this one. Okay, D L E S T X. Okay, and what you'll have then K S I T E S C D L E D L E E T X. Okay, this will be your actual data. Okay, this is your actual data. Okay, got it. So we'll move further. So that will be printed in B. Okay, so this is the explain logic of your character stuffing. Now what you'll do, we'll move on to the execution. Okay, so close. So execution, go to code blocks, then go to file, new, project, console application, go, then give next, select C, give next. This is what? Character stuffing, character stuff. Okay, give next. See to that GNU GCC compiler is there, then finish, then click on this main function, copy the program. You should write the program. Okay, copy, then paste it here. Then what you have to do, you have to save this, build it, and then run. Now it is saying enter this string. So I'll maximize this one. So it says K S I T D L E. So after stuffing, you can see here, I'll just show the pointer for you. Okay, you can see here DLESTX. Okay, then KSIT. Okay, KSIT. After KSIT, what it does, it stuffs an escape character. Okay, and next DLE, this character. Okay, because DLE is your flag pattern. Before that, an escape character. And finally, okay, you will have a end flag. Okay, so this is your output of your character stuffing. Okay, so thank you very much for listening to this video.